1 minute speaker. How are you all?
Good.
1 second. Hey, so you all did geometric probability, right? So,
Yes, actually, we did that.
Sample spaces we are done. Geometric probability we are done. Probably and okay. I want to do dependent independent probability. Venn diagrams as well. Let's see. Okay. So what we'll do is we'll do first dependent independent probability. Okay, as a part of the previous part itself, we'll do dependent independent probability, and then we'll come to this. We will match up Venn diagrams later. Okay, tree diagrams. Okay. Okay, let's see. First, I want to do dependent independent events. Okay. Okay. First, let's do, last week we said we'll do dependent independent events. We'll start with dependent independent events, right? So let me go with that. First, I thought I'll not cover Venn diagram as a part of this class, but since Manya brought it up, I really want to cover Venn diagrams as well as a part of probability. Okay, I had no plans of covering Venn diagram until she brought it up though. Okay, anyway, so having said that, Shrikar, did you get questions on Venn diagram and probability in the exam?
Probability, yes. Venn diagrams, no.
No, there can be problems using Venn diagrams in probability. You didn't get it.
No,
Yeah,
no.
see, Manya, that is an addition in this book, Springboard book. Okay, otherwise I don't see probably the Venn diagrams is a part of, but it's good to learn though. Okay. Okay, now let's go ahead and see the dependent independent problem. Guys, I really want you to be able to distinguish dependent independent events. Okay, it's pretty easy provided you get a hang of this. Now let's say there is a bag, okay, containing 3 red marbles, 3 blue marbles. There's a bag containing 3 red, 3 blue marbles. Okay, let me differentiate between both events. Okay, now, see, this is what I'm going to do. I'm going to pick a ball, replace, pick a ball. Now, the pick of the ball second time, when you pick the ball, is the status of the bag exactly the same as I do the first pick? When I pick a ball, replace, pick a ball. What happens the second time? I pick a ball. Let's say I pick a red ball. Okay. Now I put it back and make the bag the same when I pick the second ball. So can I say these two events are completely independent? The probability of picking the ball the second time is not at all dependent on the first one. Can I say that? Chetan, are you following?
Yes. Hey, can you hear me? I said yes.
1 second. Yeah, I can hear you. Okay. Can we go ahead? So here, when you do a second event, the status is exactly the same thing as that of the first event, means the two event, this is event 1, this is event 2. They are completely independent of each other. Can I say that? Let's say I am asking you in both the cases, I'm going to ask you, hey, what is the probability of picking a red and a red ball? There are two picks, right? If I ask you, what is the probability of picking a red and a red ball? You will come up and tell me, Auntie, probability of a red and a red ball is nothing here, because nothing but probability of picking a red ball first in the first pick times probability of picking the red ball in the second pick. அவனுக்கு join பண்றா. Am I making sense? See, there is no change between the two. So they're completely independent. Probability of picking a red is what everybody knows here. This is 3 red balls, 3 blue balls. So 3 out of 6 times 3 out of 6. Why multiplication? Because I need probability of red and red. Am I making sense? So it's 1 by 4. Does that make sense? Let's go to Chetan. Did you understand what are independent events? Chetan, we are not able to hear you. Maybe I am not able to hear you.
Auntie, can you hear
Yes.
me?
Yes.
Yes, I am.
Now, coming to dependent events, I'm going to do the same pick, no replace. Pick. So what do you think is the probability of a red and a red? Can I say probability of red and probability of red? Can I say like this? I can't, because after pick 1, let's say I picked up the red ball, I will assume. So the first, thanks, darling. The probability is 3 out of 6. Probability of picking a red ball from this bag is 3 out of 6. 3 red balls, 3 blue balls. But I am not putting it back. My bag completely changed. It's a chemical change that happened, right? So my bag changed. So I cannot go back because I stole my 1 red ball and I'm not putting it back. Now there are only 2 red balls. So the bag's content completely changed. I cannot write that as P of R. I have to write probability of R considering a red ball was already picked. See, there is a pipe symbol that's coming that indicates this probability of picking red is not the same as the previous one. It changed. Why? I already picked a red ball. So I call this as probability of red and a red is probability of red times probability of red assuming red was already picked. This is not going to be the same as probability of red. What is it going to be? Now that is going to be 2 out of 5. Am I making sense? Because that 1 red ball is gone. Shrika, did you understand?
The second one is depending on the first one, basically.
Exactly. That became 2 out of 5 because the total number of balls became 5 and red balls became 2. Okay. So here, this is dependent probability. Okay. This is dependent probability. One thing is sometimes they may ask you, hey, find out whether this is dependent or independent probability. In independent probability, clearly if you want 2 events to happen, it has to be the multiplied value of the probability of the first event times the second event. Then, if the probability given for two events to happen is the product of these two, then automatically it is independent. Here, when you think about it, 3 by 6 times 2 by 5. This is different. This 2 by 5 is not the same as 3 by 6. The second pick, right? The second pick is what is going to cause the difference. So the formula for this one, right? Probability of A and B will be probability of A times probability of B, assuming A has occurred. For this one, it would be probability of A and B will be equal to probability of A times probability of B. Probability of B is not caring about what happened with A. A doesn't care about B. So it's just a multiplied value. But here, the second one has to be bothered about what happened to me prior. What happened? What was the event that happened prior to this event? It has to be bothered. That's why this pipe symbol is there. You have to assume A occurred and then find out the probability of B. Did I make sense? Navneet, are you understanding?
Yeah.
Okay. Now I'm going to give you something. Let's see. Okay. I'll go with the tree diagram. Come back to the table. Tree diagram. Yeah. Let's do this one. Let's do a tree diagram based on dependent events. Then we'll come back. How about this? I don't want too many as well. Okay, how about this? Okay. I play video game. 1 minute. I play video game. Okay. Okay. I have two events happening. Okay. I play video games. One is I play video games. The second one is I play video games. Okay. When I play with video games, I connect with my friends. Meaning in the video game, I can connect with my friends, right? So 1 second, guys. 1 second. One time. Breakout room potuma. Okay. 1 second, guys. நீயே போட்டுக்கிறியா? One second, Amma. Just okay, then you can create the breakout room. Okay. So I play video games. I connect with friends. Those are the two events that are going to happen. I'm going to tell you what are the probabilities. Now, let's find out one by one. Okay. Now, before I go there, right, I want to explain some of the symbols to you. I play video games is V. I connect with my friends is F. Okay. Guys, please listen. There are some symbols I'm going to explain. Probability of playing video games is this. But what is this, guys? Probability of not, this is V complement. V complement means V does not happen. Probability, this is probability of me playing video game. This is probability of me not playing video game. Then if probability of F is, did you go to the breakout room? Probability of me connecting with friends. Then what is this? Who can tell me what is this? What is this? Probability of me?
Not
Guys,
connected.
Not connecting.
F complement is not connecting with friends. So these are exactly opposites. Probability of me connecting with friend See, the added value of these two is always 1. Added values of these two is always 1. I'll either play video game or not play video game. So definitely one of them is going to occur. You see what I mean? So when I add these two, it's going to, probability is going to become 1. Okay, so definitely this probability is going to be some decimal. This probability is going to be some decimal. Both of them sum up to 1. Similarly, probability of me connecting with friends can be or not connecting with friends. Either of that is going to happen. So the sum of them is going to be 1. But this can be 0.2 means this has to be 0.8. Make sense? Okay, now the same events are in place. Okay. How about this? The probability of me playing video games is 40%. Okay. If I play video games, probability of me connecting with friends, that is my second event, connecting with friends is 30%. If I don't play video games, probability of connecting with my friends is 90%. Okay, this is what is given. Okay, I've given you the scenario. There is dependent probability. This concept is completely based on dependent probability. Why? Because me connecting with friends and not connecting with friends is dependent on whether I am playing video games or not very clearly. So there is some dependent probability present in here, correct? So in order for me to understand this much better, right? I have to draw a tree diagram. Let me draw the tree diagram for you first. Okay, second problem you can do by yourself. First, my event is whether I play video game or not, right? So the first event is I will play video game. I will not play video game. I will play video game. I will not play video game. The probability of me playing video game is 0.4. The probability of me not playing video game then is what? 0.6, correct. Now, if I play video game, I can connect with friends or I don't have to connect with friends. Now, if I play video games, the problem states the probability of me connecting with friends is 30%. If this is 0.3, how much will this be? Of not connecting with friends is 0.7. Now, we have to come to the second one. If I don't play video games, probability of me connecting with friends is 90%. Then what is the probability of not connecting with friends?
0.1.
1. Okay. Now you have your tree diagram. My event 1 is playing video game or not. Event 2 is connecting with friends or not. Okay. So let me go ahead and keep asking you some probabilities. You can try it out. What is the probability that I do not play video games? What is the probability that I don't play video games? Can tell me the decimal answer. One of you please shout out. If it is incorrect, we'll go back. What is the probability of me not playing video games is V complement. What is that?
0.6.
0.6. Do you see 0.6? Correct. Now, what is the probability? See here. What is I showed you several symbols. What does it mean? What does this mean? What is the probability of F pipe symbol V? F pipe symbol V. I have F pipe symbol and V. Sorry. I wanted to mute. I think you muted. Sorry, I made you unmute. So now, what is the probability of F pipe V? That means who can explain this to me? Who can explain this? What is the probability of me connecting with friends given that I played video games? Who can tell me the answer for this one?
0.3.
Huh?
0.3.
0.3.
3.
What is the probability of me connecting with friends given that I played video games? One second. FRV. Given that, okay. FRV seems the incorrect. Okay. What is the probability of him given he has played video games? Okay, so that would be, okay. For this one to occur, right? How do I find it? See, okay. Now we assumed that this already occurred, right? So is what was your answer, Navneet? What was your answer?
0.3.
0.3. Okay. So here, do you see that is dependent probability? Am I making sense? Now let me ask you this. So this pipe symbol indicates your dependent probability. Now let me ask you more questions. How about he will not connect with friends? Okay. Okay. Let's say, okay, if I don't play video games, what is the probability of me connecting with friends? If I don't play video games, what is the probability of me connecting with my friends? If I don't play video games, what is the probability of me connecting with my friends?
0.9.
Yep. So these are dependent probabilities when you think about it. Let's find out more. Okay, with the same diagram, let's go ahead and try a few more. How about okay. Okay, suppose if I play video games, what is the let me ask you that. How about this? What is the probability of me playing video games and not connect with my friends? Both should happen. What is the probability of me playing video games and not connect with my friends? So both has to happen, right? Probability of V and then probability of me not connected with my friends after I played video game. It's 0.4 times 0.7. Does it make sense? Since this is dependent probability, right? It is basically dependent probability. So see here, 0.4 and then times 0.7. Why that 0.7? Probability of not connecting to friends, given 4 has already occurred, from V only I'm branching this. So 0.4 times 0.7. Am I making sense? Okay, now one more maybe. Okay, what is the probability that I don't play video games? I don't play video games and connect with my friends. I don't play video games and connect with my friends. What is the probability that I don't play video games and connect with my friends? What will I do here?
Multiply 0.6 and 0.9.
0.9. Good job. Do you all get it? Manya, how are you?
Yeah, I'm understanding it.
Now, let me ask you one more question. What is the probability I don't play video games, not play, and not connect? What is the probability that I don't play and don't connect? You think you can tell me what multiplied by what? I am not asking for the answer, only the concept. I don't play video games and not connect with my friends. What and what should be multiplied, guys? Try, guys.
0.6 and 0.1.
Correct, ma. 0.6 and 0.1 is correct. Make sense? So, this is what it is. These two are dependent events, right? Literally, they are dependent. F is dependent on whether VC or V. So, what can I say about this? Probability of VC times probability of F given VC has occurred. That's why probability of VC you did 0.6. But probability of F is here as well as here. But you are considering VC has occurred. That's why you only take up 0.6 times, you have taken VC, probability of 0.6 and then not connect with friends, I told, right? Okay, this one, for this one I'm explaining. This one I'm explaining. Probability of VC and F, right? So VC and F means I should have multiplied 0.6 and so here it would be 0.6 and this one is a dependent probability. Considering VC has occurred, what was F? That I multiply. Make sense? See, the second pick is a dependent probability here. Okay, now let me go back. I have a question for you. Chetan, was it difficult or did you get going? Huh?
It was, but once I wrote down the different numbers, it was easy. Like if I like for example, I wrote down for this it's like point something, and then for that it's that. So then it just got easy after that.
I see. Okay, let's see. 1 second. I really want to go over one problem Manya came up with. Okay. Where is that dependent? Okay. This is what I'm going to give it to you. You're going to sit and do. Okay. You're going to draw the tree diagram. I will help you later. Once you don't get, I'm going to help you. But please, I want you to try. Sean Johnson studies his current events in geometry class so that his classmate Nikit will help him. Nikit is a good student. Okay. He can only help Sean 40% of the time. When Nikit helps, Sean makes good grades 85% of the time. If Nikit does not help, Sean gets good grade only 35% of the time. So make a tree diagram. First of all, make the tree diagram. Then tell what is the probability that Sean will get a good grade. Sean getting a good grade. What is the probability? What is the probability that Sean... First, let's answer A. First, draw the tree diagram. Sean studies. Classmate Nikit helps him. That's the scenario. Okay. Nikit can only help seen 40% of the time. That means what? 60% is not going to help seen. Nikit helps. Suppose when Nikit helps, N means seen gets 85% good grades. N complement. When Nikit doesn't help, seen gets only good grades only 35% of the time. So now you have to find out the probability that seen will get a good grade. Take your time though. You have to let me know if you didn't understand, please, guys. First, draw the tree diagram. And then you need to find out seen getting a good grade means we want the probability of G.
Can you repeat the numbers one more time?
Absolutely. Nikit is the person who is helping. Okay. Seen is the person who is getting help. The problem says Nikit can help Seen 40% of the time. So 60% Nikit is not going to help Seen. When Nikit helps, Seen can make good grades 85% of the time. When Nikit does not help, Seen gets good grade 35% of the time. Did you note down, Chetan? Chetan, did you note down or do you want me to repeat?
Yes, I noted down.
Sorry, Chetan, I didn't get you. What?
I wrote it down.
Okay. So first question is, what is the probability Seen will get, Sean, okay, Sean will get a good grade.
Okay.
Draw the tree diagram. There are multiple scenarios he'll get a good grade. So you need to be careful. Did you get it? Manya, you got it, Manya now. Aditi, correct. Did you understand, Manya, now? Dependent probability?
Yeah.
Oh, nice. Or you understood already? I just wanted to know.
I mean, like, I understand it more now.
I see. Manya, the correct. Aditi, correct. Okay, you can go ahead and answer B and C, guys. If you're all good, you can go and answer B and C. What is the probability that Sean will get a good grade? See that given that Nikit helps him is a pipe symbol. Okay, they're asking, this one they're asking what is the probability of G? G means good grade. Let's say G means good grade. Then what is the other one? Helps. H means helps. If we take it like that, the first one is just asking for probability of G. The second one, what is the probability Sean will get a good grade? Will get a good grade is G, right? Yes, the same thing they're asking. But they're assuming something has occurred. So that is on a pipe symbol and H. H was the thing that occurred. You just need to find out G, assuming H already occurred. So basically G and H are the events. Okay. G and H are the events. Right? G and H are the events. Oh, wow. Everybody has answers. Wow, I'm impressed. I don't know whether to get impressed at myself or you. Because did I explain it well? I'm wondering. Srinitha, I feel like correct, Ma, but the first one seems incorrect. Manya correct, Aditi correct on the second one. First one, Srinita, did you draw the tree diagram? Navneet, for the first one, Srinita and you, did you understand? I doubt. Okay, let's draw. So I did not reach you properly. Let's see. Nikit is a good student to pay. Okay, Sean. Okay, Sean, 40% of the time. 40% Nikit is helping. Okay, help, H complement, not help. Okay, so helping is 40%. Complement is 6. Okay. Now, if he helps 85%, he gets good grade. So 0.85, 0.15. Similarly, not help, he gets good grade only 35% of the time. So the rest 55. No, 65% of the time it is not good grades. They're asking for the first one, they're asking probability of G. G can happen here or can happen here, right? Now, for this G to happen, this both should happen. For this G to happen, this both should happen. So you need to multiply these. So basically for this G to happen, the probability is this. For this G to happen, the probability is this. After I multiply, I can add them together. Aditi and Srinita, did it make sense?
Yeah.
I got the answer right.
Oh, sorry. Srinita and Navneet. I got confused. Sorry, Maditi. Navneet, did you get it right?
Yeah, I understand it now.
But wait, second one, what is the probability that Seen will get a good grade given that Nikit helps him? So what is that? Nikit already helped him. So this already occurred. You don't have to bother. This already occurred. They are given that. What is the probability of G? That is 0.85. Make sense? So here this is 0.4 times 0.85 plus 0.6 times 0.35. You have to add both. Am I making sense? Are these independent events? They are not independent events because him getting good grade is really dependent on whether Sean is helping him or not. Okay, now Chetan, did you get the answer for the first one?
Yeah.
What was it? Or second one?
Huh? Supposed to multiply the two probabilities of him getting
Correct.
good grades.
Correct. And then add them together. Does it make sense?
Wait, add them and multiply them? What do you mean?
Illa. First multiply them together, meaning how, okay, if suppose Sean, Nikit is helping, right? At that time, what is the probability of Sean getting a good grade? 0.4 times 0.85. Nikit is not helping. What is the probability of him getting a good grade? 0.6 times 0.35.
Oh, okay.
You got it? So both you'll add together. But for the second question, what is the probability of getting good grades given that Nikit is helping him? So Nikit is already helping him. You are there already. But then after that, what is the probability of him getting a good grade? It's just 0.85. Make sense?
Mm-hmm.
Okay, good. Hey, Shrikar, I'm not getting answers from you. What does it mean?
I'm trying to figure it out. What?
You're trying to figure out what? Shrikar, if you're not attentive, this happens. I'm very sorry to pick that out, but yeah, that's what it is. Otherwise, you should have asked by now. You see what I mean? I was just waiting whether you'll ask the question as well. First one I explained. Second one I asked you to do. No questions absolutely from you. So what should I do? I want to move on. I can't pull down the class as well. Can I move on? Okay, let's do one more. Let's do one more of this, okay? So dependent, independent events we need to do. Let's see. Do I have one more? Yes, I have. Mm. Mm. Okay. Okay. A class has 10 girls and 15 boys. 25 is 2, 2 by 5. 2 by 5 is 4 by 10. Correct. Okay. 10 girls and 15 boys. Okay. I will choose 2 class monitors. I will choose 2 class monitors. That's all. That's all I'm given. Okay. Part tree diagram I'm going to give you. You're going to fill in the tree diagram. Okay. Picking a girl, picking a boy. The first class monitor picking a girl, picking a boy. This is 0.4. Now I'm telling this is 9 by 24. Do you see why it is 9 by 24? What does it mean? What will come here? Can you tell me what is A? What is B? What is C? What is D? Not a difficult one. I just want the values of A, B, C, D now. In the tree diagram, Chetan, just wait on the questions. Chetan, you can solve the questions. Right now, we are filling up the diagram. So we will finish up the diagram, then come to you for the questions. A class has 10 girls and 15 boys. I have drawn a tree diagram. I'm going to choose 2 class monitors. Okay, so 2 class monitors means picking one class monitor, pick class monitor, pick class monitor. Those are the events, right? Now, what should be the value of A? Anybody can shout out.
0.6.
Not 0.6, because 0.4 was the probability of picking up a girl. How did that 0.1 come? There are 10 girls and 15 boys. So the chance of girl getting picked is 10 out of a 25, which is 0.4. The rest of it is 15 by 25, which is 0.6. Now, after picking up the girl, one girl disappeared. So it is 9 out of a 24. So this should be G or B. Here, this should be G or B. What should be there? The 9 out of 24 represents G or B?
G.
B. Why? Because one girl disappeared. The rest of them are 9 out of 24 students in the class. So this has to be B then. Now, what is the value of B? Easy, guys, this one. What is it?
15 by 24.
15 by 24. So tree diagram filling is quite easy. Now, here you understood. Okay, the first class monitor being a boy is 15 out of a 25. Now, after picking the boy, what is the chance of a girl or a boy for the second monitor? So what fraction should come on the C or the D? What fraction should come on the C or the D?
Would C be 10 over 24?
10 over, why 10 over 24? 15 only one boy went out. One boy was picked as a
14 over.
14 over 24.
Oh, sorry.
Good job. No problem. Then this one, D. Wait. 40. illa. Who said? See, this one is a girl, right? This one is 14 over 24. For the boy, it's 14 over 24 is correct. For the girl, 24 is the denominator. That's correct. But for the girl, how many girls are in there at this point?
10.
10 over 24. Because 10 girls are safely there. Boy was picked, right? Now, can I ask you questions? Okay, for Chetan, let me read out. Chetan, the probability of a girl first being picked as the class monitor is 0.4. So the first class monitor being a boy is 0.6, Chetan. Then the second class monitor being a girl is 9 out of a 24. And the boy being picked is 15 out of a 24. The second class monitor, after the boy gets picked up as the first class monitor, the probability of getting a girl as a second class monitor is 10 by 24. And the boy being picked is 14 by 24. Did you note that down? Now let me ask you, let me give you the probability of, what is the probability that the class monitors are 2 girls? What is the probability that the class monitors are girl and boy? What is the probability that there are 2 boys? Want 3 answers. If you get these right, our target is reached. Oh, wow. Shrikar, you got the answers. Very nice. Okay, let's see. Girl and a girl. Aditi, correct, ma'am. Yeah. Shrikar, I just want the answers for 1, 2, 3. 1, 2, 3. Second one seems incorrect, ma Aditi. I think you're missing something. Aditi, girl and a boy can be boy and a girl as well, right? You see, so you need to add one more probability. I said the probability of the monitors being boy and a girl. I should have written it like that, I feel. Probability. Class monitors are girl boy combination. Girl boy combination. Manya, girl and a girl. Manya, give me the decimal value, Manya. Don't make me count, ma. I think that's right, Manya, though. I myself multiplied it and saw. Aditi, second one is correct. You got it, Aditi?
Yeah.
Right, Manya, correct, the first one.
Miss Priya, can you check my last answer?
Okay, Manya, the G plus B combination, Manya, can also be B plus G, right? It can be a boy and a girl or a girl and a boy, right?
Wait, but I calculated both of those and I got the same thing.
Correct. So add them together, right? It can
Oh,
be
okay.
either. It can be this or that, right? So you need to add. You got it?
Yeah.
B and a B can answer. Yeah, Manya, third one is correct. Wait, Navneet, there are problems. Third one is correct, Manya. Aditi, correct. Okay, Aditi and Manya, done for now. Okay. Now I have problems with Navneet's answer. Navneet, first answer is correct, Navneet. Second answer and the third answer seem incorrect. Okay. Navneet, boy and the girl combination, right? Boy and the girl combination means what? Let's say first the girl was picked, boy was picked. This is one right combination. The second right combination is boy and the girl. You see? So both the probabilities should be added. For both the probabilities means 10 by 25 times 15 by 24 plus 15 by 25 times 10 by 24. Correct, Navneet?
Yeah.
So each will be 0.25, 0.25, right?
Mm-hmm. Yeah.
So when added, it will be 0.5. Make sense?
Oh yeah, never mind. I'm into
Samantha, where are we,
0.5.
Samantha?
I understand this. Like,
Really?
it doesn't
Very
seem hard.
good. You joined very late, right? That's
Yeah,
why.
I was outside, but it's like it feels like common sense to me. So it's not. I don't think it's hard based
Okay.
on whatever I saw.
So the third one, boy and a boy means what? Boy and a boy means this one. Boy and boy combination, both should happen. So it's 0.6 times 14 by 24. Make sense? Navneet.
Yeah.
Srinita, did you understand?
Yeah, I understood.
How about you, Chetan? What was the girl and the girl? Or am I Chetan? Okay, okay, let me ping him. Okay. Now let's go ahead. Okay, that one is good. The Venn diagram we'll see next week, but how about this? I really would like one more. I really would like conditional probability based on a table. Okay, so let's see this one. I'll give you same, okay, same instead of a tree diagram, I'm going to give you a table. You're going to, or why don't we discuss this question? One last simple question we'll discuss, okay? So, Seema, in probability, there are other symbols that you need to know. See here, probability of event A and B. This is intersection. Intersection means A and B. Okay. A union B is more of an OR. Okay. If two events, this or this means you're going to add the probability of this and this. Intersection means you're going to multiply both the probabilities. How do you do this? How do you do this? How about this? I have this male, female. 1, 2, 5, 4. This is under 20 over 20. Now, the table shows 4 categories into which the contestants of some competition are categorized into. Okay. Now you can put total here, total here. That is all left to you. Okay. So the number of males total is, females total is 6, under 20 total is 3, under over 20 total is 9. So basically your total should come as the same. Total is always row total is 12, column total is 12. Now, can I ask you probabilities? What is the probability? What is the probability of a female? If I select a contestant at random, what is the probability of it being a female? You want to chat or you want to shout out?
Would it be 1/2?
Yeah. So probability of a female is 6 out of a total of 12. Correct. Which is half. Okay. Now, I'm going to discuss dependent events. What is the probability of a female given we picked a person under 20? We picked the person under 20 is given. Okay, you can't change that. But what is the probability of a female under
1/6.
Yeah, 1/6.
1/6.
What was that, Shrikar? What was that, Samantha?
1/6.
Yeah.
It's 1/6, let's see. Under 20. Under 20 total is 3. Okay, what is the probability of it being a female?
2.
2/3, right? It's 2/3, right?
Oh, female over under. Oh.
You
I
get
thought
it?
it was female that's under 20 out of like the total.
Yeah. See, under 20 is done. That is your denominator. You get
Yeah,
it?
I didn't think that was a slash symbol. I thought that was like
Okay,
and I
you are
don't know.
not there then. Okay. What is
Yeah.
the probability of a female being picked who is 20 or over? Now I want everybody's answer in chat.
How many people are there in total?
Chetan, you came back, huh? Okay. Or in total, okay. Now, let me read out the table for you. Male, female, male under 20 is 1, female under 20 is 2, male over 20 is 5, female over 20 is 4, Chetan. Did you note down?
So that's 12 in total.
12 in total. Under 20 total is 20. Over 20, sorry, under 20 total is 3. Over 20 total is 9. Male total is 6. Female total is 6. Now, what is the probability of a contestant being chosen is the female given she is 20 or over? Correct. Who got it correct? Navneet got it correct.
Okay.
Srinita, no. Why? Srinita, which ones are you choosing? See, 20 or over is given. Within that only I need to pick because that is the assumed value. That is the assumed one. It has already happened. Over 20. So out of 9, I have to pick. What is the probability of the female? It is 4. 4 out of 9. Manya, did you get that?
Yeah, I sent my answer.
Oh, okay. Does it make sense?
Yeah.
Okay. Now quickly, yeah, I'll ask one question to you all. Let me see whether you're getting it. Here, is this dependent event or independent events? If I give you like this, right? See, this is A and B. Probability of A and B is 0.5985. Probability of A is 0.95. Probability of B is 0.63. Are they dependent or independent events? How will let's talk it out? Meaning, let's discuss that. How will you check that, guys? As I said, right?
Maybe like to see if they are related to each other, like if they're equal to 1.
Probability of A and B, if it is equal to probability of A times probability of B, then they are independent. You got it? So if the two product is equal to this, then they are independent. Make sense?
Yeah.
Suppose if they ask you like this, probability of an event B is 0.6. Okay. Probability of the same event given A has already occurred is 3/5, which is 0.6. Are they dependent events or independent events?
Dependent.
If they both are different,
Oh, never mind, my bad.
then they are dependent. If they both are the same exactly, then P did not care whether A occurred or not.
Oh, I didn't simplify the 3/5, that's why.
Oh, okay. Okay. 3/5. So this is 0.6 only. So see, they both are the same. B always has the probability of 0.6 irrespective of A occurred or not. So these are independent events. Any questions?
No.
Okay. I'll stop here, guys. Any questions for me? Stay. Manya, you got a good insight right now.
Yeah.
Okay. Do your review and let me know what happened.
Yeah. I had just another thought. Like today morning, I think I went home or I went and I did some problems like in the packets that they've been giving and it really helped. So do you think you could squeeze in another class before
I will run away, ma. When is Thursday is your test? Huh?
Yeah.
I'll let you know. Huh?
Okay.
Yeah, I'll definitely let you know. Today's my problem is a pre-cal class I cancelled and I've scheduled it on Tuesday, which is too much on me. I feel which I rescheduled on Thursday. I'll let you know. Huh?
Okay, yeah.
Even if you meet half an hour is okay for you.
Yeah, that's okay with me.
Yeah, I'll let you know.
Okay.
Yeah, probably, yeah. Okay, on Tuesday probably.
Yeah.
I'll let you know, ma. Okay.
Right. Yeah.
Bye.
Thank you.
But you understood better, huh?
Yeah, I understood much.
I'm glad I could see it.
Yeah.
Bye. Bye.